So our lesson today is on congruent figures, and we're covering two lessons out of our text, 3.2 and 3.3, and I have the same EQ there for both of them because they're close enough that I could just use the same one. How can you determine whether two figures are congruent? And we have some I can statements, which are our learning goals. I can determine whether two figures are congruent using rigid motion transformations. So remember, we learned about those before we went on break. There's three types of transformations that are rigid. We have translations, which are slides. Those are rigid motions. We have reflections, which are flips. Okay, those are rigid. And we also have rotations, which are turns. Okay, those are also rigid motions. I can determine if two triangles are congruent using CPCFC. Okay, so that's just an acronym to represent something that we'll be looking at today. It's a theorem. I can use the definition of congruence to find missing parts of a figure. Okay, we'll be able to do that. And I can infer which parts of congruent triangles are congruent. And we'll be doing that as well. So first we're going to look at our vocab so we know what we're talking about here. And let's just take a look at the congruent symbol first, which is in the upper right-hand corner. It is composed of two other math symbols together to create it. So that wavy on its side looking thing is a similarity. It's a similar symbol. So if two things are similar, that's the similar symbol. It means the same shape. And then the equal sign, you recognize, I'm sure, that means equality, which is the same size. So if I put those two together, we have the same shape and same size, which is our definition of congruent as well. So the symbol for congruence is the wavy thing and then an equal sign under it. A similar symbol and an equal sign under it. And then if we look at the vocabulary, congruent is having the same size and shape, okay? And also congruent angles. So if we talk about two angles that are congruent, that's going to mean that they have the same measure, okay? Two angles that are congruent have equal measures. The word corresponding means to appear in the same place in two similar situations. So if you have two triangles and we talk about corresponding, we want to talk about the same side lengths, okay, or the same angles, okay, in the same two places, but on the different shapes. That's corresponding. And then congruent figures are when you have two plane figures, plane as in the two-dimensional coordinate plane, two plane figures, whose corresponding sides and angles are congruent, have the same shape and size. Okay, so when we talk about rigid motion transformations, I kind of just mentioned this to remind you guys we're talking about reflections, rotations, and translations. And this is true that two plane figures are congruent if and only if one can be obtained from the other by a sequence of rigid motions. All right, so those rigid motions are reflections, rotations, translations. And this is just a little chart here to show you that the congruence transformations consist of those three. And then there's a couple examples or in a single example of, you know, what the coordinate notation looks like for some reflections or rotations. Okay, reflections over the x-axis, over the y-axis, those are the coordinate rules there. But we also have coordinate rules for over y equals x and over the line y equals negative x. And you can look at our cheat sheet that I kind of reposted to you yesterday in our translation assignment yesterday to get all the rules. Or you can go back to your notes and get all the rules. For rotations, we typically look at rotations around the origin, around 0, 0. And we look at them in 90-degree increments. And so we just have one example here, 180-degree rotation around 0, 0. What you do is you take x, y, and it turns into negative x, negative y. And then finally, translation. And this is from yesterday, the assignment you had yesterday, something that we need to kind of cover a little bit more, because when we write the coordinate rules for translations, what you're basically writing, and a lot of you missed this question on the test or the retest, is that your x value is going to change by either adding a number or subtracting a number to the x value. So if you go to the left, that means you're subtracting a number, or you can think of it as adding a negative. If you go to the right, you're adding a number. For the y coordinate, it's y plus b, where if you're moving up, then you're adding that many units up. If you're moving down, you would be adding that many negative units, or you can think of it as subtracting a number. Okay, so that's the rule for those. Okay, so same idea, just here's a specific example. Okay, so we have the coordinate plane, and in there we have two figures, two plane figures, and they appear to be the same size and shape. So to say that they are congruent, we look for one rigid transformation or a series of rigid transformations that would map one image to the other. So it looks like our original image, the pre-image, is CDEF, which is on the left-hand side. And we can map it, okay? Map means to transform it onto JKLM by doing one transformation of a reflection over the y-axis. Reflections are rigid, so therefore the two figures are congruent. And if you wanted the notation for that, you take your xy value and you change the sign of the x, and then you just keep the y coordinate the same. Okay, so here's your first interactive slide. And so I'm going to give you about 3 minutes to do this one. So what you're going to need to do is just tab over to the Pear Deck tab if you're not in it right now. And you're going to type your response. Determine if the figures are congruent. Explain your answer. So I just showed you an example like this on the last slide. And now you're going to try one of these. So determine, are those two figures congruent? And tell me why you think they are or are not congruent. And so I'm going to give you 3 minutes to do this. So someone said yes, they are the same size. So if two figures are the same size, that for them to be congruent, they have to be the same shape as well. So that doesn't really cover it. It says, I believe these figures are congruent because they are the same shape and size. Good. And they are just turned at different angles. Oh, okay. Maybe they're turned at different angles. Maybe it's a different type of transformation. I don't think it's a rotation. Yes, I think they're congruent because they have the same shape and size. Yes, that is true. Yes, they have the same shape, same size and shape, just looks like it's reflected. Good. It does look like it's reflected. That's true. Yes, they are the same shape and size. It is simply a reflection. Yes, it is. Okay, so you can see our original figure up here, ABCD, to our figure below is being just reflected. Okay, and where are we reflecting over? What is our line of reflection? Let's see, did someone figure that out? What is the line of reflection? Not the y-axis. They are, because if you flip the top one over the x-axis, it will line up exactly like the one under the x-axis. Yes, this is a reflection over the x-axis. That is absolutely correct, the x-axis. So that's your mirror line. That's where you're flipping it over, reflecting it over. Okay, good job. Same size, same shape. Yes, definition of congruence is when two figures have the same size and the same shape, they are congruent. Okay, and two plane figures are congruent if and only if one can be obtained from the other by a sequence of rigid motion. Since we had a reflection, all right, that means they are congruent. Okay, good. And so this is back from our ICANN statements. I told you we had this acronym CPCFC. Okay, and so what that stands for is corresponding parts of congruent figures are congruent. CPCFC. This is a mathematical theorem. Okay, the theorem says if two figures are congruent, same shape, same size, then the corresponding sides are congruent and the corresponding angles are congruent. So that's what we call CPCFC, that the corresponding parts, the sides, and the angles of two figures that are congruent are also congruent themselves. And so that's what this picture is showing you. At the very bottom, you can see it says triangle ABC is congruent to triangle DEF. And all those little tick marks in the pictures between the two triangles, we have on the side lengths, you can see that the ones that have the same length, okay, they have the same tick mark. So there's a 1 tick mark, there's a 2 tick mark, and a 3 tick mark. And that shows that they have the same length. And then with the angles, those angles, the corresponding angles are congruent. And the same thing with those tick marks. Again, that's a way of identifying angles that have the same measure. All right. So I put this in here. I like this slide a lot. So one thing really nice about mathematics is that once you learn how to use the notation, you really don't have to write very much at all. Okay, mathematical notation is, it's a language. And so if you look at the far left column in this slide where it says symbols, there's 3 rows of symbols, right? And then if you look all the way over to the right where it says meaning, and there's 3, looks like, I think they're sentences. There's 3 sentences of words, okay? The symbols on the left and the words all the way on the right, they mean exactly the same thing, but it's so much less writing. So if you don't like writing a lot out, math is really awesome when you can use the notation, okay? And so this is notation with the way you read it is the middle column. The words column is how you read that notation. The symbols column is how you write that notation. And then the meaning column is what it actually means. So like the first row, the way you read those symbols is side AB is congruent to side DE. And what that means is the side of the triangle marked with AB and the side of the triangle marked with DE are the same length. All 3 of those columns mean the same thing. One is like really concise and easy to write, and then one is like a lot of words. So that's just how you do math notation. And then the next row down, we read that as angle B is congruent to angle E, which means the angle marked by the corner B and the angle marked by the corner E have the same measure, the same number of degrees. Okay, and then the last row, triangle ABC, is congruent to triangle DEF, is how you read that. And it means that the triangle ABC and the triangle DEF have the same size and shape. They are congruent. All right. So again, this is CPCFC. And just looking at these 2 triangles in this picture, when 2 figures are congruent, the corresponding sides, okay, if they're triangles, there's 3 sides. And the corresponding angles, if they're triangles, there's 3 angles. They are all congruent. So from this picture, if we know triangles ABC and triangles DEF are congruent, then we can conclude this row of statements about the congruent side lengths. Okay, and that's all notation. So like if you wanted to write that out, you have, you know, just one of those notations with all that meaning. You'd have to write all this wordy stuff 3 times just for that. And then the angles that are congruent. Okay, same thing here. We're writing this type of notation 3 times. It'd be like writing this 3 times. It'd be writing this 3 times and this 3 times. That's so much writing. But this is so much more concise and neat, and it's really cool about math notation like that. All right, so we are now at the part where I'm going to kind of turn you loose for a bit, and you have a few slides I'm going to have you work on. You're going to work on slide 9, you're going to work on slide 10, and you're going to work on slide 11. And so I'm going to put you into student pace mode. Okay, got it. And I'm going to give you until 45. Okay, so until 10:45, you have to work on these 3 slides. And here's somebody who did it correctly. XY, side length XY, so they have the bar on top, is the same length, congruent to, okay, that's a little squiggle with the equal sign, and then side GH, GH with the line on top. Here's another person that did it correctly, a little bit larger. There's another person that did it correctly. Okay, so I had 3 of you that did that correctly, and so that's what I was looking for. Slide 10, I'm really proud of you guys on slide 10. Look at that. Every single person that tried it got it correct. Yeah, I know once I say that, someone's going to move their star to the other side. But yeah, so if I hide all your stars, the 2 congruent triangles are here. They're the same shape and size. There is a sequence of transformations that will map one to the other. Basically, it's a translation of, you know, if I'm taking the one on the left, I'm translating it up 3 units, and then I'm reflecting it over the y-axis. A translation and a reflection, those are rigid motions, therefore they are congruent. Whereas this one on the left, these are not the same size. They're the same shape, I think. Okay, they might be similar triangles, but they are not congruent. And then the last one here, this one was the toughest one. Okay, there's a lot of pieces to it. And so when you're doing these types of problems where you have to write in the different pieces that are congruent to the given piece, okay, the angle or the side, sometimes it's useful to just look at the picture and figure out like PQ. PQ is here, all right, so that's congruent to side length ST because it's in the same spot but on the opposite triangle. Another thing you can do that's I think even easier is if you look at the original statement where they tell you that the 2 triangles are congruent, triangle PQR is congruent to triangle STU, the order of these letters counts, all right? I cannot put them in a different order. PQR to STU. So because I'm taking PQ here, I have to take the first 2 letters of this one, ST, which means QR here, QR, I have to take these 2 letters, TU. RP, well, it's the last letter and the first letter, so I have to do that over here. I have to take the last letter, U, to the first letter, S. Okay, and so I had 1 student that I found, actually 2 students I found that did it all correctly. Nice work. They have the correct order of the letters. They're all in capitals, and they have the correct symbols. Okay, and so when you do the angles ones, like angle T, angle S, angle U, well, you can look over here and use the picture. The T is corresponding to Q, or P is corresponding to S, or you can look at the original statement, the original congruent statement to see, well, if S is the first letter, then we're talking about the first letter. If we're looking at the last letter, U, then we're looking at the last letter, R. All right, so that's good to keep in mind. These 2 students did an excellent job. That is the end of this lesson. I have one last thing for you to do before you leave today, which is a quick little poll. And I just sent it out to you. Okay, I'm going to put this back on student paste. Okay, so in the Google Meet, a poll popped up at the very top right corner. There's like a little blue dot and a little shaped thing. And so by clicking on that, it's just a quick poll about how you feel about today's lesson. Was it easy peasy? I think I understand, or I am confused? Okay. And so it's anonymous. No one's going to see your answer, but it's for me to kind of gauge how you guys are understanding what we just covered today. For the rest of our week, tomorrow you have a reflections assignment in HMH, and then on Thursday I'm going to have you watch the video of our lesson that we just did today, and you're going to take some notes on it. Okay, and then on Friday we have a CAMI assignment about this. Okay, so once you take the poll, real quick question, you are free to leave the meet and have a great day.